Hey everyone, and welcome. So today, we're diving into a really fascinating scientific detective story. It's got everything: a super bold experiment, a discovery that could change the world, and of course, a critical clue that almost everybody missed. All right, let's get into it.
Okay, so this quote right here, it really gets to the heart of what they were claiming. Lorentz symmetry is basically one of the absolute cornerstones of modern physics. It says the rules of the universe are the same for everyone, no matter how you're moving. And these researchers were saying, nope, we found an exception. That's not just a small discovery. That's the kind of thing that creates a whole new branch of physics. We're talking about rewriting the textbooks from the ground up.
So, what did they actually say they did to get there? Well, when you boil it down, it sounds like something straight out of an old story: modern-day alchemy. They claimed they could create brand new elements just by blasting liquid mercury with sound waves. A truly extraordinary claim, for sure.
So let's break down exactly what happened. The project was called the DST Mercury experiment. And the setup was, basically they took liquid mercury and blasted it with powerful ultrasound. When they analyzed the sample afterward, they reported finding 13 new elements. Elements that just were not there when they started.
And take a look at this list. I mean, what's so wild is just how random this all seems. You've got super light stuff like lithium, all the way up to heavy radioactive thorium. And yeah, you're seeing that right. They even reported finding gold. It's just a bizarre collection of elements to seemingly appear out of thin air.
So the study gets published, and this huge claim of new physics is out there. But then, an analyst, a sort of armchair scientific sleuth named Nick Fenning, decided to take a much closer look at their data. And he spotted something, a hidden pattern that the original researchers had totally overlooked. And it changes everything. Okay, so this is where our detective story really kicks into gear. Fenning's big insight was to stop focusing on how these elements might have been made, and instead to look very closely at which elements they were. He had a hunch that this seemingly random list wasn't random at all.
And as he started digging into the physical properties of these 13 elements, he found this unbelievable connection, a common thread that tied every single one of them together. I mean, the question is, what on earth could something like lithium possibly have in common with gold and thorium? But before I tell you what it is, just look at this number. The odds of 13 elements chosen at random, all happening to share this one specific property just by chance, it's about 1 in 62,800. You know, in science, that's not a coincidence. That is a blinking red light, a massive clue.
So what is this mystery property? It's superconductivity. And if you need a quick refresher, think of it like a perfect highway for electricity. When a material becomes a superconductor, electricity can flow through it with zero resistance, literally zero energy loss. It's a very special quantum state of matter.
And boom, this is the big reveal. 100%. Every single one of the 13 new elements they found is known to either be a superconductor itself or to form compounds that are superconductors. Even mercury, the starting material, was the first superconductor ever found. This perfect correlation is the massive clue that the original team just missed.
All right, so a hidden pattern is one thing, but that's just the start. Fenning also found something missing from the original experiment. A critical piece of data that they absolutely should have measured, but they didn't. See, there's this thing that's super well known in physics. If you hit a liquid metal with powerful ultrasound, exactly like they did in the experiment, its electrical resistance just plummets. And it's not a small change. We're talking a dramatic, well-documented collapse.
So you'd think this would be the first thing you check, right? If you're creating some kind of extreme environment inside your Mercury and claiming new physics, you'd probably want to measure one of the most fundamental properties of that environment.
The answer? A flat-out no. They never measured it. They jumped straight to a conclusion about new physics without ever checking a key variable that is known to change dramatically under their exact experimental conditions. This is the smoking gun.
So, with the new physics idea looking pretty shaky, Fenning came up with a much simpler explanation, one that, doesn't require us to throw out a century of physics. He called it the runaway galvanic boost, and it's all based on science we already understand.
Okay, so here's how it works. Think of it like a feedback loop, or a snowball rolling downhill. First, the ultrasound makes the mercury superconductive. That lower resistance allows local electric fields to get stronger. Now, if any new little clusters of atoms start to form, only the ones that are also superconductive can survive and grow in that environment.
This creates a self-reinforcing cycle that only allows for one type of outcome: stabilizing elements that are, you guessed it, superconducting capable.
So, what we're left with are two completely different stories to explain what happened. On one side, we have the original team's extraordinary claim of new physics, and on the other, Nick Fenning's much more conventional, condensed matter explanation.
And this table just lays it all out, crystal clear. The original interpretation hinges on a radical idea like deformed space-time, but it completely ignores the two biggest clues, the superconductivity correlation and the missing resistivity measurement. The other view, however, uses a known mechanism. It perfectly explains the 100% correlation, and it's all grounded in established physics. The evidence is just overwhelming.
You know, this whole story is just a perfect textbook case for that famous saying, extraordinary claims require extraordinary evidence. Before you leap to a conclusion that rewrites the laws of physics, you first have a responsibility to rule out every possible explanation using the physics we already have.
And just to be super clear, the big takeaway here isn't that the data was fake. It's entirely possible they really did detect those elements. The problem wasn't their observation, it was their interpretation. They jumped to a revolutionary conclusion because they overlooked the simpler, more logical explanation that was sitting right there in the data all along.
And that really leaves us with this final, kind of mind-bending thought. This whole case shows how tempting it can be to chase after a revolutionary idea. And it just makes you wonder, how many other scientific revolutions out there are just waiting for a sharp eye to find the missing clue that connects it all back to the physics we already know and understand?